Good morning, students. Let's start our chemistry class. We are discussing chapter 2, structure of atom, and we have discussed about Thomson, Rutherford's and Bohr's model. And after Bohr's model in 1933, it was for approximately 10 years that model was in use, but later on in 1924, after the discussion of dual behavior of matter by de Broglie's concept and Heisenberg's uncertainty principle. Various drawbacks of Bohr's model came into notice, and after that, it was very important to have a new approach towards the structure of the atom. Let us discuss that new concept of structure of matter that is called quantum mechanical model. Firstly, we'll see what is quantum mechanical approach. Quantum mechanics is a branch of science that takes into account the dual behavior of matter, because classical physics deals with the particle nature of the matter and it could not explain the motion of microscopic particles. Rather, it can explain the motion of macroscopic particles properly using Newton's law of motion, but those laws cannot be applied here when we talk about the motion of electrons and other microscopic particles. So this branch of physics or science, you can say, was developed by two scientists, Werner Heisenberg and Erwin Schrödinger, in year 1924 to 1926. Classical mechanics actually fails to explain the motion of microscopic particles because it doesn't consider the dual behavior of matter. And Bohr's model also described a well-defined path of electron in circular orbit moving around the nucleus. Whereas Heisenberg uncertainty principle proved that existence of definite path or trajectory cannot be considered. Means it doesn't it is not possible to find out exact position, means we cannot define the exact trajectories of electron. And the fundamental equation of quantum mechanics was developed by Schrödinger later, and it won him the Nobel Prize in 1933. So what is this equation? Actually, Schrödinger solved equation for the wave nature of the particles, and he used a wave function for this wave nature, and the symbol which he used for wave function is psi, that you can see in this equation. Delta square psi over delta x square means psi is, he calculated this value of psi wave function for electron in 3 dimensions x, y and z, and he arrived at this equation, but the solution of this equation is not in your syllabus. Quantum mechanical model of atom is actually based on considering the wave nature of the electron or the other particles, and it is a result of Schrödinger's wave equation when applied to hydrogen atom first. And let us discuss important features of this model. First one, the energy of an electron is quantized. As suggested by Bohr also, electronic energy is not any arbitrary value, means electron in an orbit cannot have any energy. Like arbitrary value is not possible for energy, कुछ भी value आप assign नहीं कर सकते. Rather, energy of an electron is quantized. It has a specific value and it changes by a certain specific whole number. As you can see here, when we consider, if we consider a ladder, then rungs correspond, each step you can say correspond to energy level. And if you want to put your foot, so you cannot put your foot anywhere in between these two rungs, that is 1 or 2 step के बीच में आप अपना पैर नहीं रख सकते. तो either you can put your foot at first step or the second or the third or the fourth. So these you can consider that these are the quantized energy values for an electron that it can have, or you can say these are the fixed orbits where electron can exist. Means electron cannot remain in between the area from 1 to 2. So you can say that electronic energy is quantized. And these quantized energy levels are direct result of wave properties of electrons, and Schrödinger calculated formula for finding energy of an electron in hydrogen atom. En is equal to minus 2 pi square me4 over n square h square, and this is the same formula which was earlier derived by Bohr. So in both of the concept, this main concept is same, that energy of an electron is quantized. Next, where quantum mechanical model differs with Bohr's model is that according to Bohr's model, path of an electron in an atom is fixed and electrons revolve around that nucleus in that fixed orbit. This was according to the Bohr model. But quantum mechanical model actually eliminates the possibility of calculating exact trajectories of an atom. According to Heisenberg's uncertainty principle, we cannot find the exact position and exact velocity of an electron in an atom. Hence, path of an electron can never be defined. And this is the main point of quantum mechanical model, where it deals with not the exact position of electron, rather it takes into consideration the probability of finding. Means, according to this model, what we assume that electrons do not revolve in that particular orbit, rather that they revolve in a particular three-dimensional region around the nucleus, and this region cannot be defined by fixed boundaries. Rather, it can be considered as an electron cloud. This particular region, as you can see here in the picture, this whole cloud is shown around the nucleus, whereas closer to the nucleus this cloud is quite faint. Means वहाँ पर इलेक्ट्रॉन के प्रेजेंट होने की प्रोबेबिलिटी जीरो है, उसके बाद वो इलेक्ट्रॉन के प्रेजेंट होने की प्रोबेबिलिटी उस पूरे इलेक्ट्रॉन क्लाउड में कहीं पे भी हो सकती है. मीन्स अकॉर्डिंग टू बोहर वो एक फिक्स्ड ऑर्बिट में ही इलेक्ट्रॉन रहते हैं, बट that is wrong. Heisenberg's uncertainty principle explained that electrons cannot, location of electron you cannot assign. So this electron cloud is used to represent the location, and this is called probability of finding an electron in a three-dimensional region, and it was named as orbital. So concept of orbit is now changed to orbital. Next, an orbital is the wave function for an electron in an atom. Schrödinger calculated the value of wave function three-dimensionally, and he named it as an orbital. An orbital is a three-dimensional region where probability of finding electron at a point is maximum. And this probability of finding electron is also calculated by Schrödinger's wave equation by taking the square of wave function. And he calculated all those possible values of wave function and probability in three-dimensional region around the nucleus. And it was possibly assumed, it was possibly described by him that there are various three-dimensional regions having different shapes and sizes around the nucleus, which are called orbitals. Next, we can have a difference between orbit and orbital. As we have seen in Bohr's model, that these are the fixed path which are called orbit, in which the electron is present. Whereas according to modern concept quantum mechanical model, there is not a specified region where the electron is present. Rather, there is just a probability of finding electron in a particular region, और जहाँ तक वो probability होती है वहाँ तक electron cloud मतलब you can spread that electron cloud up to which, and the point where its probability becomes minimum or zero, उस जगह पे इलेक्ट्रॉन की possibility बहुत कम होती है. तो these three-dimensional region where electrons can be present anywhere is called orbital, and orbits are the fixed path in which electrons revolve. Orbit is a two-dimensional planar structure. You can say it defines two-dimensional motion, whereas in orbital it defines three-dimensional motion, and it's a three-dimensional structure of atom. Next, we list out the difference between orbit and orbital. A well-defined circular path around nucleus where electron revolves is called orbit, whereas three-dimensional region around nucleus in which probability of finding electron is maximum is called orbital. Orbit represents 2D motion, orbital represents 3D motion of electron. Orbit is not in accordance with uncertainty principle, whereas orbital is in accordance with uncertainty principle of Heisenberg. All orbits are circular in shape, only the sizes are different, but the shape is circular, whereas all orbitals have different shape. They may be circular, they may be dumbbell shape, they may be or other shapes we will discuss later. And orbits do not have directional characteristics, means they are symmetrical because they are circular in shape, whereas orbitals have directional properties that we'll discuss under shapes of orbitals. Next important concept of quantum mechanical model is that quantum numbers, means each and every electron can be assigned a set of few numbers which are called quantum numbers, and these numbers actually you can say like address of electron, कि वो electron कहाँ पर है, किस shell में है, किस orbital के अंदर है, किस तरह का उसका orientation है 3-dimensional space में. तो each and everything can be assigned to an electron by using these 4 numbers which are called quantum numbers. So out of these 4 quantum numbers, 3 quantum numbers were given by Schrödinger, whereas the 4th quantum number was assigned to electrons later. So these quantum numbers are designated by 4 symbols: N, L, ML and MS. And these are you can see here in this picture, N is principal quantum number, L is angular quantum number, ML is magnetic quantum number, MS is spin quantum number. Let us discuss them. First one is principal quantum number N. It represents the main energy level. Actually, this principal number is taken from the Bohr's model. Actually, Bohr ने जो assign किया था orbit, you can consider that electron cloud also extends up to that region. कि एक जो orbit है वो fixed boundary तो है, but उस radius तक आप assume करो कि electron cloud वहाँ तक spread हुआ है. तो वो exactly वो path नहीं है, but area वही रहेगा. तो this principal quantum number is taken from Bohr's model and it represents the number of shell actually. N means number of shell, that is principal quantum number. For K shell it would be 1, for L it would be 2, as you know. And it determines the energy, because as we know that energy continuously increases when we go on or when we go away from the nucleus. So K shell has minimum energy, whereas the outermost shells have higher energy. So if we know that where is the electron present at a time, so we also know the amount of energy it will have. So it determines the energy of an electron. It gives average distance of electron. एक idea आपको मिल जाता है कि कितनी distance पे वो electron present होगा. तो average distance of electron from the nucleus we can have, because if we know the shell, so we know the radius of the shell also. It determines the size of electron cloud. अब electron cloud का size भी n ही बताएगा आपको, क्योंकि electron cloud का size कितना होगा वो depend करेगा शेल जो है बोहर के मॉडल के अकॉर्डिंग, कि शेल की जो रेडियस है उतने ही डिस्टेंस तक वो इलेक्ट्रॉन क्लाउड वहां पे प्रेजेंट होता है. मींस थोड़ा सा डिफरेंस है ऑर्बिट एंड ऑर्बिटल में. ऑर्बिट वो फिक्स्ड रेडिया है, बस उसी रेडिया को अब आपने एक फिक्स्ड पाथ में कंसीडर नहीं करना, रादर अ स्प्रेड इलेक्ट्रॉन क्लाउड is the orbital. So size of electron cloud around the nucleus can be determined by principal quantum number. Next is azimuthal quantum number L. It represents the angular momentum of an electron and it is represented by the symbol L. L actually can have values ranging from 0 to n-1. मतलब एक particular n वैल्यू के लिए L की जो वैल्यूज है वो 0 से n-1 तक हो सकती हैं, and each value of L is corresponding to a subshell. and if the number of L is 0, then it would represent S subshell. For L is equal to 1, it represents P subshell. For L equals to 2, it represents D subshell, and for L value 3, it represents F subshell, and for L value 4, it represents G subshell. So actually now you can think that बोहर ने सिर्फ ये बताया था कि मेन शेल है, बट अब क्वांटम मैकेनिकल मॉडल इससे आगे जा रहा है, जो हम कहते हैं कि एक इलेक्ट्रॉनिक एमिशन स्पेक्ट्रम में लाइंस क्यों स्प्लिट अप हो जाती हैं. एक पर्टिकुलर लाइन भी जब उसको आप सोफिस्टिकेटेड स्पेक्ट्रोस्कोपी के अंडर स्टडी करते हो तो वो फाइन लाइंस में डिवाइड हो जाती है. उसका रीजन क्या है, और जंप्स क्यों पॉसिबल है एक ही शेल में? दैट इज बिकॉज ऑफ ईच शेल is further divided into subshells. और ये subshells आपको कैसे पता करनी है, एक शेल में कितनी subshells होंगी? That will given by this L number, angular momentum of the electron. So this decides the number of subshell, as well as you can see that each subshell has a specific shape. S subshell has spherical shape, P subshell have orbitals in the shape of dumbbell, D subshell have double dumbbell shape, and F subshell are actually multiple lobe structures which are more complex in nature. So we can determine the shape of an orbital or a subshell in which the electron is present by looking at the value of L. And it also determines the relative energy of an electron. Means अगर आपको L वैल्यू पता है एक इलेक्ट्रॉन की, तो आप उसका relative energy भी बता सकते हो, क्योंकि एक ही पर्टिकुलर शेल में सारे इलेक्ट्रॉन्स की एनर्जी सेम नहीं होती. अगर वो इलेक्ट्रॉन S सब शेल में है तो वो लोएस्ट एनर्जी पे होगा, देन P एंड देन D एंड फाइनली F और G. मतलब जितना हम सब शेल्स में आगे S P D F G की तरफ जाएंगे, विद इंक्रीज इन वैल्यू ऑफ L 0 to 4 or so on, the amount of energy or the energy of the electron increases. So electron in S subshell have least energy. So we can also have the idea of relative energy of the electron. And it also gives the number of subshells in a particular shell, and the number of subshells are always equal to the total values of L. Next is magnetic quantum number, ML. It is actually determines the spatial orientation of an orbital. Orbital क्या है? 3-dimensional region है around nucleus. अब वो region 3-dimensional region space 3-dimensional space में किस तरह से oriented है, means in which directions it is oriented, that is represented by this number. And it can have values ranging from -L to +L, including 0. So there are total 2L plus 1 values of ML for each L. मतलब L की वैल्यू अगर 0 है, have a look at the diagram now. When L is 0, तो M की वैल्यू कितनी होंगी? 2L plus 1, 0 obviously, so that will be only 0. And for this 0 value of L and 0 value of M, we can have only one orbital which is spherical in shape, and it is symmetrically distributed in all 3 dimensions x, y and z, and it is called S orbital. For value of L1, we can have 3 values of M, like -1, 0 and +1. As you can see here, these 3 orbitals are represented by yellow color. These are called as L1 के लिए सबशेल कौन सी है? P सबशेल के लिए 3 orbitals हैं, Px, Py and Pz. And for L is equal to 2, ML की वैल्यूज कितनी होंगी? 5, -2, -1, 0, +1, +2. एंड फॉर दीज 5 वैल्यूज, एक्चुअली ये 5 ML वैल्यूज कहाँ से आ रही है? इनके डिफरेंट ओरिएंटेशन से, कि D के जो ऑर्बिटल्स हैं, D सबशेल के 4 जो लोब्स होते हैं इसके, वो किस डायरेक्शन में ओरिएंटेड है. ऑन द बेसिस ऑफ दैट 5 ऑर्बिटल्स पॉसिबल हैं, and these structures of these orbital we'll discuss in next lecture. And next L is equal to 3 values. We have 7 ML values, -3, -2, -1, 0, +1, +2, +3. तो ये 7 orbitals possible होते हैं F subshell के लिए. तो you can see that number of orbitals in a particular shell is equal to the number of M values. So now the main thing in this model is that each shell is divided into subshells. Each subshell further have a fixed number of orbitals. S subshell only have 1 orbital, P subshell has 3 orbitals, D subshell has 5 orbitals, and F subshell has 7 orbitals. Next we can have notations for various subshells. अब किस तरह से आपने L और M वैल्यूज को देख करके सबशेल को नोटेशंस देनी है. तो सबसे पहले N की वैल्यू N, पॉसिबल वैल्यू ऑफ L 0, क्योंकि L ऑलवेज हैव वैल्यू n-1, 0 to n-1 तक ही L की वैल्यूज पॉसिबल है. तो फॉर दिस वैल्यू ऑफ N विल बी हैविंग ओनली वन वैल्यू L 0. एंड सबशेल क्या होगा, नोटिफिकेशन, इसके लिए नोटेशन जो हम यूज करेंगे N1, तो 1 आपको लिखना है साथ में, और 0 क्या डिसाइड कर रहा है, सबशेल S, तो वी कैन राइट इट एज 1s. और इस 1s सबशेल के लिए n की वैल्यू क्या हो जाएगी, 0 है तो उसके लिए ऑब्वियसली 0. तो नंबर ऑफ ऑर्बिटल्स इन दिस, बिकॉज एक ही ओरिएंटेशन पॉसिबल है, नंबर ऑफ ऑर्बिटल इज 1 एंड टोटल नंबर ऑफ ऑर्बिटल्स इन फर्स्ट K शेल विल बी 1 ओनली. नाउ वी डिस्कस N2. N2 किसको रिप्रेजेंट कर रहा है, K शेल को. तो 2 N वैल्यू 2 के लिए आपके पास L की वैल्यूज कितनी आ जाएंगी, L वैल्यूज होती हैं 0 से लेके n-1 तक. तो पहली 0, दूसरी 2 - 1 1. तो ओनली 2 वैल्यूज आर पॉसिबल फॉर L इन सेकेंड शेल. तो सेकेंड शेल की इन 2 L वैल्यूज के लिए आपके पास 2 सबशेल्स आ गई, 0 के लिए S और 1 के लिए P, और इनको असाइन करना है अपने n नंबर यूज करके. तो 0 S और 2 आगे साथ में लगाना है. तो 2S and 2P विल बी 2 सबशेल्स फॉर द सेकेंड शेल. K शेल में 2 सबशेल हैं, 2S 2P. एंड इसके लिए M वैल्यूज यू नो दैट 0 है तो 0 ही होगा, 1 के लिए -1, 0 + 1, और इन तीनों के लिए ये ऑर्बिटल्स 3 हो गए. S सबशेल हैव 1 ऑर्बिटल, टोटल नंबर ऑफ ऑर्बिटल्स इन K शेल 3 + 1 4. सिमिलरली इन थर्ड शेल N की वैल्यू 3, पॉसिबल वैल्यूज ऑफ L वुड बी 0 1 2, क्योंकि 0 से रेंज करेंगी 2 तक, 0 1 2 3 वैल्यूज आ गई, मतलब टोटल नंबर ऑफ सबशेल्स होगी आपके पास 3. अब इन 3 सबशेल्स के नेम क्या होंगे, फर्स्ट वाली जो 0 वाली है 3S, जो L है दैट इज L1 के लिए जो सबशेल है दैट इज 3P, एंड फॉर L वैल्यू 2 इन थर्ड शेल. थर्ड शेल के लिए हम नंबर यूज कर रहे हैं 3 और 2 के लिए हम यूज कर रहे हैं D. तो 3D will represent the D subshell present in third orbit, that is M orbit, M shell. And possible values of M 0 से लेके मतलब 0 के लिए 1 ऑर्बिटल, P के लिए 3 ऑर्बिटल्स, D के लिए 5, तो टोटल 9 ऑर्बिटल्स आर प्रेजेंट इन थर्ड M shell. Now fourth shell N shell के लिए L की वैल्यूज होंगी 0 1 2 3, बिकॉज L की जो टोटल नंबर ऑफ वैल्यूज हैं वो N नंबर जितना प्रिंसिपल क्वांटम नंबर है उसके इक्वल होती हैं, बट रेंज जो होती है 0 से n-1 तक. तो 4 सबशेल्स वुड बी देयर एंड दीज सबशेल्स कैन बी रिप्रेजेंटेड बाय दीज नोटेशंस 4S 4P 4D 4F. मतलब 4 आपको लगाना है, जो नंबर शेल का है उससे उठाना है, ये फर्स्ट जो होल नंबर हम ले रहे हैं. उसके बाद SPDF जो डिपेंड करेगा आपके L वैल्यू पे. उसके बाद पॉसिबल वैल्यूज M देख के कितनी वो वैल्यूज है उतने ऑर्बिटल असाइन कर दीजिए. तो टोटल नंबर ऑफ ऑर्बिटल्स इन L सबशेल N सबशेल फोर्थ N शेल दैट इज फोर्थ शेल इज 16. So next fourth quantum number is spin quantum number. It is given in 1925 by George Uhlenbeck and Samuel Goudsmit. They actually realized the necessity of this quantum number because electrons, while revolving around the nucleus, it also rotates on its own axis, which is called spin of electron. And this spin quantum number determines the spin orientation, means in which direction electron is rotating on its axis, and it is represented by ms. Since electron can rotate either clockwise or anti-clockwise, hence this quantum number can have only 2 values, and these values are independent of अदर क्वांटम नंबर. जैसे बाकी एक दूसरे के साथ डिपेंडेंट है, इनका उससे कोई रिलेशन नहीं है. किसी भी ऑर्बिटल के अंदर जो इलेक्ट्रॉन होगा वो या तो +½ उसका स्पिन क्वांटम नंबर होगा या -12 होगा. तो there are only two orientations of electron spin can be possible, and they can also be represented by using arrows. Upward arrow for clockwise rotation, downward arrow for anti-clockwise rotation. So in this way, each orbital can have only two electrons. One will be of positive spin or clockwise spin, second will be of negative spin. Let us now discuss total number of orbitals and electrons present in a particular shell. Let us see in K shell. As there is only one subshell because L has just one value 0, and for that M has also one value 0, so that will also have one orbital. So one S subshell will have one orbital, and each orbital can have two electrons because of two possible spin. So that is 2 electrons are present in K shell. Next we have L shell. L shell has n value 2, and for this n value 2 we have 0 and 1, 2 L values. So for 0 value of L we have just one M value, and that will be for, and 0 is for S subshell. So here L n value 2, so subshell will be designated as 2S. So 2S will have 2 electron. Similarly, second value of L will be 1 for n value. So this orbital will be, or this subshell will be designated by 2p, because 2 is from the n value and p is for L1 value. L1 is equal to p. So 2p subshell, because it has 3 m values, -1, 0 and +1. So there are 3 orbitals possible in p subshell. So we will have total 1 plus 3, 4 orbitals in L shell, and total 8 electrons. Now in third shell, which is called M shell. M shell has n value 3. तो प्रिंसिपल क्वांटम नंबर 3 के लिए L की वैल्यू आपके पास आ गई 3, 0, 1, 2. 0 के लिए आपके पास 3s सबशेल, L के लिए 1 के लिए 3p सबशेल, D के लिए you have 3, L is equal to 2, you have 3d subshell. One orbital is there in 3s, 3 orbitals are there in 3p, 3d because it can have five m values, -2, -1, 0, +1, +2. So there are 5 orbitals in 3d subshell. So total 1 plus 3 plus 5, 9 orbital. Each orbital will have 2 electrons, so total 18 electrons. Now fourth shell, N shell. प्रिंसिपल क्वांटम नंबर 4. तो L की वैल्यू टोटल कितनी हो जाएंगी? 4, रेंजिंग फ्रॉम 0 to 3. 0, 1, 2, 3. 0 के लिए 4s, 1 के लिए 4p, 3 के लिए 4d and 4 के लिए 4f. 0 के लिए 4s, 1 के लिए 4p, 2 this 4d and 3 के लिए 4f. And for each value of m you can have 1, 3, 5 and 7 orbitals. 7 orbitals for 4f because 4l value 4f के लिए 3 है, तो -3, 2 plus 3, total 7 values are possible for m. So you have 16 orbitals total here for fourth shell, and 16 multiplied by 2, we can have some 32 electrons can be there. Total number of atomic orbitals in fourth energy level of atom. Fourth energy level जो है मतलब n shell के अंदर टोटल नंबर ऑफ एटॉमिक ऑर्बिटल्स अभी हमने निकाले. टोटल नंबर ऑफ एटॉमिक ऑर्बिटल्स इन अ पर्टिकुलर शेल कैन बी गिवन बाय दिस फॉर्मूला n square. तो n square, n is 4, 4 square 16. तो total answer is 16 here. And second question, maximum number of electrons in a subshell of an atom is determined. कितने electrons एक subshell में आ सकते हैं? तो remember this small formula, number of electrons in a subshell is given by 4l plus 2. So this is the formula, 4l plus 2. Number of electrons in a shell can be given by 2n square, but in subshell can be given as 4l plus 2. Next, the maximum number of electrons that can have principal quantum number n is equal to 3. अ स्पिन क्वांटम नंबर ms इज इक्वल टू माइनस हाफ, मतलब शेल थर्ड है और स्पिन क्वांटम नंबर माइनस हाफ है, तो टोटल ऐसे कितने इलेक्ट्रॉन होंगे जिनका स्पिन माइनस हाफ होगा थर्ड शेल में? तो थर्ड शेल में टोटल नंबर ऑफ ऑर्बिटल्स वुड बी n स्क्वायर, 3 स्क्वायर 9 ऑर्बिटल्स हो गए, हर एक ऑर्बिटल में माइनस हाफ वाला एक इलेक्ट्रॉन आएगा, दैट मीन्स टोटल नंबर ऑफ इलेक्ट्रॉन will be 9. Next, consider the following sets of quantum numbers. n, l, m, s की वैल्यूज गिवन है. अब आपको इसमें से बताना है कौन सा पॉसिबल नहीं है. तो फर्स्ट ऑफ ऑल वी हैव अ लुक एट दिस. 3, n वैल्यू 3, l1 पॉसिबल, l0 पॉसिबल, m भी 0, ठीक है, ms भी ये करेक्ट है. 2 के लिए 2 ये रॉन्ग है. सेकेंड इज रॉन्ग बिकॉज l कैन नॉट हैव वैल्यू इक्वल टू n. थर्ड 4, 3, -2, minus half, this is also correct. Fourth 1, 0, -1, this is wrong because m cannot have value more than 0, more than l जितना है उससे ज़्यादा m की वैल्यू, मतलब 0 है अगर तो -1 पॉसिबल नहीं है, तो दिस इज अगेन रॉन्ग. नेक्स्ट इज 3, 2 वैल्यू है l की, तो -2 से +2 तक वैल्यू जा सकती है बट उससे ऊपर नहीं जाएगी, तो ml has 3, तो दिस इज ऑल्सो रॉन्ग. तो here we can have that these 3 options, second, fourth and fifth, are not possible. So these kind of quantum numbers are not possible. So in this way you can attempt this type of question related to quantum numbers. It's a very important topic of quantum mechanical model and the entire chemistry also. So